Hi guys, Miss Simmer here. I'm going to go over a few of the basics of trinomials first, and then we'll talk about some of the harder problems that you guys encountered in your homework. First, let's look at three trinomials. All right, so first thing I notice is what the constant sign is, because that's going to tell me when I'm factoring these, are the signs the same or different? This tells me these are the same. They're both going to be negative with an x squared in the front because that's a coefficient of 1. X times x is x squared. Here I see the same sign, and it's going to be positive x and x because that's a coefficient of 1, and x times x is x squared. So notice both of these have the same signs, but it's the middle one that tells me whether it's positive or whether it's negative. Now here, this one is negative. So this one tells me the signs are going to be different. One's going to be positive, one's going to be negative in order to combine to make a -2. Still x and x because coefficient of 1. So how do we decide what number goes there? Well, hopefully you've discovered that as you factor, you're looking for numbers that add up to -8. So -3 and -5 in any order would be -8. So first, x squared, outer and inner, -5 and -3x, give us -8x, and last, +15. So when you're done, you can multiply it out and make sure you've got the right answer. Now, the next one, factors of 8, 1 and 8, 2 and 4. Clearly, 2 and 4, I'm sorry, this is supposed to be a 6 here. Can't believe I copied that wrong. 2 and 4 are the ones that are going to add up to 6. If there had been a 2 there, that would be a prime. Prime means you can't factor it. So at that point, I would have known I can't do it. But here I can do it because I have +6. So 2 and 4, they multiply to 8, and they add up to 6x. Now, the last one, this is the one that's different. Well, my factors of 35, 1 and 35, 5 and 7. Well, since the signs are different, when I add them, I'm actually subtracting to get a -2. So what's going to give me a -2? Well, I've got these numbers. Clearly, the difference is 2. If 7 is negative and 5 is positive, they will multiply to -35, but they will add to -2. So that's my answer. Checking first, x squared, outer, -7, inner, +5x will give me -2x, and then multiply -35. All right, so hopefully that helped you review the simple trinomials, and remember you can always FOIL them and check your answer before you submit. So no reason to miss any of those. Now let's move on. Don't forget to take out a GCF. There were several times when if you didn't take out a GCF, it would be a problem. So let's go with this problem. Hopefully I copy it down correctly. 14x squared y squared plus 68x y squared minus 210 y squared. So what can we take out? Definitely a y squared. When you're looking at the coefficient, 1, 2, 7, and 14 are factors. So 1 doesn't count. 2 is a factor, clearly, because they're all even. 7, we can try them out. It's a factor here, but 7 is not a factor of 68. So that's not a factor. 14 is not a factor either. I already checked it out. And if 7 doesn't go in, 14 is not going to go in. So now 2y is our GCF. remember we're going to go to each one of these and we're going to take out, 2y squared. This is where I need you guys to raise your hand and tell me I made that mistake. Luckily, I caught it myself. So 2y squared is our GCF. Taking that out, 14 divided by 2 is 7. X squared does not cancel. Y squared does. Y squared cancels again, plus 34x, because the x does not cancel out. 210 divided by 2 is 105, and that y squared cancels out. Okay. Now, at this point, you can check out your trinomial and see, can I factor this? Well, what we can do is we can try out, because these are larger numbers, we can try out our box method, and let's see how it goes. Okay. Now, I'm not concerned about the GCF out front, just this trinomial. Okay. Now, 7 times 105. Let me get my calculator here, and we can check that out. And we get 735. We're like, wow, those are some big numbers. Well, let's see. 7 and 105 multiply to that, and their difference is 98. So maybe we get some numbers that are closer together that might work out. I know that 5 goes into it, but that's not going to help very much. So let's see what other factors of 735 might be. Let's try 15. 15 and 49. Oh my goodness. Bingo. Those subtract to 34. And remember before, negative sign means the signs are different. Positive means that the higher number is positive. This one's the negative number. Now, the higher one's going to go here. The smaller number is going to go here. Now, for the box method, we have to do some factoring out, just like we did for this number. Factor out across this way. What goes in to 7x squared and 49? Just 7. Oh, I forgot the x. Don't forget, box method, these have to both be x. We're going to put x behind them. So now it's 7x that factors out. Here, what factors out? 15. I'm going to make it negative 15 because they're both negative 15. And we don't have an x in both, so just negative 15. What factors out going this way? Well, just x. What factors out this way? Well, I don't think anything else is going to go into 105. Just double checking. Oh, 7 does. So 7 goes into 49 and 105. Just double checking. 105 divided by 7, because that's the factors of 49. So 7 goes in and nothing else. And let's see. We've got our signs. Let's double check our signs now by multiplying this out. Probably the number one way that this could go wrong is having the wrong signs. Well, one thing that I know is my signs are different, okay? I only took a negative here because they were both negative. So now first, 7x squared, outer, plus 49x inner, 5x, and last, plus 35. Well, it didn't work out too well because we have 105 that we need here, not 35. So what did I do? $49.15. So let's try it the other way. Let's put 15 here and 49 here. If at first you don't succeed on that, swap them and then double check. So smaller number at the top, larger number at the bottom. And let's do some factoring again. And then we can double check it, and it better be the answer this time. So this is a really good example of how you still have to check your answer because all you need to do is put one thing in the wrong place. All right, so here, what do they have in common? Just x. Here, what do they have in common? The 7, that's positive. What do they have in common here? They have negative 15. And here, what do they have in common? 7x. So let's try 7x minus 15 and x plus 7. That's looking better. Outer 7x squared. Okay, first, now outer 49x, inner negative 15x, and last negative 105. Bingo. So all we had to do was swap these two. So we knew which ones went in there. We just have to check out the order. So smaller one up there and larger one there. These add up to positive 34. This is negative 105, 7x squared. So here's our factoring. We just need to put our GCF in the front. And that's the answer if you're not sure what the answer is at this point because there's a lot on the board. So don't forget to take out that GCF. And then, of course, because it's a box method, it's a little bit harder. I use the box method when the lead coefficient is a larger number. Even after we factored out the 2, we had a number that was not 1, and we had a constant that was 105. Now, what do you do if you just want to use trial and error? Well, let's see a good problem for trial and error. Because when you have large numbers, sometimes trial and error is the worst possible choice. Okay, so for trial and error, let's look at this one. 2x squared plus 8x minus 10. All right. 2x squared. Okay. Just want to make sure. Well, I actually have a GCF in this one too. So I'm going to go ahead and take that out so you won't have to do work too hard there. Just checking my notes. So now here we've got a 2. We're back down to a trinomial with a coefficient of 1, keeping the 2 out front. Our signs are going to be different. 1 and 5 are the only factors. Well, which ones are going to add to 4? Negative 1 and positive 5 will add to 4. So that's why the 5 is going to go here and the 1's going to go here. Okay. So that gives you another one with a GCF, but not quite as complicated as the last one. All right, let's go to what if we have one that's a perfect square? Well, they're not necessarily going to just tell you it's a perfect square. So let's start with this. How do you know? Well, first, when you look at this, you'll go, Simmer, there is another GCF in there. You're right, there is another GCF. It is p squared. And we have 16p. Let's take p squared out of each one. So we've got 16p squared minus 40p plus 25. Well, I took the p squared out, but I still have some big numbers. If I try to do the box method here, it'll work. It'll take a while, but it will still work. However, what I notice is this. These are both perfect squares. 16 is 4 times 4, and 25 is 5 times 5. So before I do something like the box method that takes a lot of steps, I want to do this. What is the square root of 16 and the square root of p squared? What is the square root of 25? Okay, so if just a reminder to take the square root of this, all you have to do is divide it by 2. Okay, so if it was 4, you would divide it by 2. Obviously, we had already taken that out, so it's taken care of. Now, multiply these numbers together. 4p times 5 is 20p. Is this number twice as, 20p. Is this number twice as much? Yes. That is a sure sign that it's the box method. Don't worry about the signs. So if you multiply this by 2 and you get the same number, it's a perfect square. So the big sign is, are these squares? So what do we do with that? Well, we go back to the fact that we have 4p and 5. We take 4p and 5 twice. What are the signs when it's positive? The same. And where do we find it? Right there. The same and negative. And this is your GCF that you took out. We have our answer, which can also be written as p squared, 4p minus 5 squared, to sum it up. So either one of these is our answer. Okay. Final thing I want to go over. Let me give you one more example. Let me crunch one more out real quick. All right, I'm just doing some quick magic here, giving you another problem because I just thought of another circumstance that would probably be helpful. Okay, let's try this. We're going to do a trial and error, but we're going to start this way. First, what's wrong with this problem? The square is in the wrong place. Right, so let's rearrange it. Now what's wrong with this problem? There's a negative up front. We need to get rid of that. All right, we're almost there. Now we just need to do a little trial and error and factor this out. Well, we know the signs are going to be the same. We know that because that's positive. Now, we've got a problem here because 1 and 6, 2 and 3. Either one could be the front factors. In fact, I'm going to move these over a little bit more space because we're going to fit a number in there eventually. But notice in the back, 1 and 2, those are the only factors. So let's check it out. Here's trial and error. Do you think 1 and 6 are going to work out too well? I don't think so. I'm going to go ahead and try 2 and 3. And by the way, if you're doing trial and error, you usually start from the bottom up on your factors. So let's just plop in a 2 and 3 and try it out and see if we like it. First, 6x squared, outer, 4x, inner, 3x, last, positive 2. Oh my gosh, it gave me the wrong, oh, it gave me the right sign. Sorry, I'm looking too far up. It gave me 7x. It gave me 2. So I did a good job the first time. If I had put 3 and 2 here, this would not have worked out. It would have come out to 6, it would come out to 8. So I would have just swapped them and tried them out. So it just so happened I hit on the right one first. I made it look super easy to do trial and error, but sometimes it can be complicated because you have 4 possibilities, 1 and 6, 2 and 3, or 3 and 2, 6 and 1 in those first 2 spots. But luckily it worked the first time, and here is your answer. I hope this was helpful. Send me some more problems, and hopefully I will see some of you guys on my live feed this week on Schoology Conference. Bye.